Hey, there we go, we're live. So this is me. My name is Dave Boyne. I'm from the UK. I'm a developer advocate at AWS. Been here for about 18 months, and I mainly focus on serverless and event-driven architectures. Is anyone building on serverless on AWS? Hands up. Okay, so it's about 30%. Previously, before I'd done that, I worked in large enterprises, leading teams, worked in startups, actually building event-driven solutions. That's why I love it so much, because I saw this agility that event-driven architectures provided, and I just needed to dive deep into this. And then open source, I actually took time out to do open source full-time with event-driven architecture space to help write some tools and standards so people can get on board. So that was good fun. And my job here today is actually to navigate you through this journey of an event-driven system. And this is what we're going to be talking about. So the first question is, where do we start when we build event-driven solutions? Now, there's a common path, and we'll be speaking about this. We're going to be speaking about the problems with this path and why we might want to do something else. We're going to then dive into implementation phase. So when we start to understand our events, our architectures, our boundaries, what patterns do we have to help us there? And then finally, operational maintenance, something we don't speak about a lot. So 12 months, 24 months, or in the future, how do we make sure that what we have is what we started with, and we can have this agile, we can have this event-driven solution, and all these benefits that we're promised. Throughout the talk, and there'll be a summary at the end, and loads of resources at the end to dive deeper yourself. I want to just start off by saying this, that the adoption of event-driven architectures is actually is growing. Right? I've been in this space full-time for about 5 years now. And there's this term and these words keep coming up. And in fact, it's nothing new, right? And if you go back decades before I was born, and now I know a lot of you thinking I look pretty young, but I'm definitely not young. But if you go back decades, actually go to old white papers, there are event-driven solutions and patterns in all of this. So why all of a sudden have we got like EDA Day, for example, here in Nashville, and why are we talking about event-driven solutions so much? And it's because I believe that event-driven architecture is becoming more accessible to us, right? And James mentioned some of this stuff in the keynote, as we lower the cost of integration, we can actually explore and experiment. But examples here, we have Lambda. Is anyone using Lambda here? Cool, about 40%. So Lambda being able to do some compute based on some events. So when something happens, we can run some compute in a runtime you might be familiar with, right? When we link this up to API Gateway, this might actually be a HTTP request coming in, and then we can do the compute there. Step functions we also have. Is anyone using step functions? Okay, yeah, a handful of people. So step functions is this orchestration tool. So we can say, okay, do this, do this, do this, do this. We have actually visual editors at AWS to be able to help this, which is fantastic. But how do you trigger a step function? Again, it's an event. An event bridge, hands up for event bridge users. Just curious. Cool, yeah, again, handful. So event bridge is this, James mentioned this in his talk. Event bridge is a router, a serverless event bus. So personally, one of my favorite services before I joined AWS, I've done a lot of tools and a lot of work with EventBridge because it allows us as publishers to publish an event, and we have these downstream consumers actually listen and react to these. And then finally, we've got DynamoDB here, which is like we can actually listen to changes in the database, listen to creates, updates, and deletes, and react to these, right? Very interesting patterns emerge. But when we talk about event-driven architectures, and then we start to look and we research and start to implement, you see these common terms like a producer, we have a channel, maybe a message broker, and we also have consumers. But when you start diving into event architectures, start implementing them, and lifting that bonnet up, you'll actually see that event-driven architectures is much more than this. And in fact, an event-driven architecture is this journey that we go on. We don't just one day wake up and say, I've got a producer and now I've got a consumer, I'm event-driven. There is much more to it than that. Now, if we map this out on this kind of visual, on this journey that we'll be going on, at the top here, we have the benefits of event architectures. The whole reason we want to use event-driven architectures, this business and agility, this decoupled architecture, being able to experiment and evolve our architectures. And I've been on teams where we've implemented this, and it is there. And the teams that I've been on had this agility in over 15 years that I've never seen before. So I'm a huge fan for event architectures. But there are common pitfalls that we see as you go along this journey and you start implementing. Understanding synchronous versus asynchronous, thinking about your boundaries, unclear information inside your events, and there are common problems that we'll see. And we're going to be diving into each one of these sections, and I want to start off by the first one. It's like, where do we start? Where should we start? And where do people normally start and the problems that you might face? The first thing is, why do we care about events? Okay, this is an important one. So think about a modern application tends to have state and tends to have events, right? So an example would be pizza ordering examples. Who likes pizza? Hands up. Most people. Who likes pineapple on pizza? There we go. Eric's a big fan. So you've got the tables, you've got the state. So I have an application, I'm ordering pizza, so I go fetch some information. This could be a query, right? We're querying for some information. No doubt this is going to come from some table somewhere. Now, every organization I've worked with, everyone is interested in events. Okay, so what did the customer do? Dave, what time did Dave wake up today? What time did he order pizza? Why did he drop off? Why did he pick pineapple? Why didn't he pick this one? We're trying to figure out what our users are doing on our applications. And events can really help us dive deeper. And what you'll find with most modern applications, we have events and we have state. And again, we spoke about this, the benefits of event architectures. Why do we even care? Why should we care? And there are some huge benefits, actually. We have this loosely coupled systems, right? Team topologies in your organizations. As teams grow, as your organization grows, we have teams that we need to communicate using the messages and events. And scalability and also extensibility, being able to extend our architecture as we move along. And the benefits are there, for sure. But the big question is, where do we start? And you'll often see there are two main places where we can start here, which I've distilled it into. One is we start implementing, right? We take a shortcut across this journey, and we start implementing event-driven systems. The other one is we take a second to think about the behavior of our systems, right? There are big differences here. And I'm going to talk you through each one of them. First, starting with implementation. When you start implementing your event-driven solution, you'll see this. You have this immediate kind of jump in value. That we have the initial producers and we have the initial consumers. So we have things connecting, we're using events, we have the scalable architecture and things are happening and it's awesome. We have more consumers and more producers and consumers as time goes on. Now, what typically tends to happen is this value that you got kind of tends to plateau as time goes on. Why is that? When we map the complexity of event-driven architecture, this tends to happen. We have our initial producers and consumers, that's fine, the complexity is kind of rising. But as you can see here, we have things like the assumptions are made, maybe unclear boundaries, what goes inside our events, what should we include in our events, how do we discover events? Well, what's this domain language, this ubiquitous language that we need to include in all of this architecture? And things can get complicated pretty fast. And let's have a look at an example of this. This is how complexity grows. So here's an architecture that will be referenced in throughout this talk. It's a very basic architecture. We have the order service, and then we have some consumers downstream. We have a fulfillment, invoice, and forecasting. We're using an event bus in the middle to be able to do something. We want to notify downstream consumers something has happened. So we, as the order service, decide, yes, we can create the order created event, right? This is, yeah, let's just do it. Let's just add some code. So we decide to do that, right? We want to add some code. Now, for those who've not used EventBridge, this is an EventBridge event, but this could be any message broker, I guess. At the top here, we have the detail type. So this is how you define in EventBridge what the event is. So we know that an event is an immutable fact, and we decide to say, yes, this is the order created event, right? This happened. Order created, the intent is there. People should understand this. Next, we use the source here to say, okay, well, which domain has raised the event? We decide, well, it's the orders domain. That is fine. Now, this is where the interesting part happens. This detail object in EventBridge, but again, other messaging platforms too, your payloads, what goes inside of them? So here we decide we're going to place the order ID and the user ID inside this event. What could go wrong? So we move on. Downstream consumers got notified, everyone is happy. 3 weeks, 6 weeks, or 3 months down the line, we get another request, order cancelled event, right? Okay, well, we can do that with the order service. We just did this. So we decide to create the order cancelled event. Now, we decided to add a reason to this, that it's no longer needed, okay? Okay, the reason no longer needed kind of makes sense to a downstream consumer, maybe, maybe not. Next one we have here is type TW. The order was cancelled because type TW. Does anyone here know what TW means? Literally no one. I have no idea what it means, and I made the slide. But what I'm getting at here is the order service is now leaking implementation details. TW means nothing outside of this domain. Down here, we decide to have the user. We had the user in the other event. We had the user ID. But now we have an object. OK, maybe this is good, maybe not. Now, why is the first name and last name in the event? Can the consumer have this? Are we regulated? Can we actually share PII information in our events? Maybe, maybe not. And as time goes on, because we're just implementing, we get these requirements in, we design our events, and we continue to implement. We have the order updated event. And in fact, as time goes on, we just raise more and more and more events, more domains, and more events, maybe even more routers and event buses. We start to end up in this weird ecosystem. Another thing that typically tends to happen is this, that unclear domain languages arise with this pattern. So an example would be, I worked at a company before I was at AWS in a startup, right, selling insurance, life insurance to customers. And we, as the development team, we had this idea of a policy, right? And the development team here, we said, well, the policy belongs to the user, okay? This is it. We're going to model this inside our code, inside our events. Now, when we integrate with the insurer says, no, hang on, the policy is something completely different. The policy belongs to us, and the user so happens to be part of that policy. So completely different languages here, but we're using events to communicate with each other in this messaging. And the underwriter actually comes along and says, no, 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 you got it all wrong. The policy is something completely different. So through this implementation first phase, we start to have this mess of unclear information. And what it tends to lead to is this, which is like this big ball of mud. It's actually a domain-driven design term here. But like unclear boundaries, unclear intent, unclear discoverability, and we just have these things talking to each other because this architecture is naturally kind of grown. And the interesting thing here is, this is from Alberto, the author of Event Storming. But this is a common problem, that is the developers misunderstanding that gets released into production, right? And talking about understanding, if we rewind a minute and think about where do we start with our EDA journey, what happens if we actually decide to actually understand the behavior first before implementation? What benefits can we get? When we do implementation first, what we mean really here is understanding the behavior of our system and actually collaborating with domain experts, actually figuring out where the boundaries of the systems are, identifying events in your system, right? Events, sometimes they can be technological things, but also there might be business domain events, right? Things we're interested in. So getting the experts in the room together and collaborating. And also this idea of this ubiquitous language at the end, talking about this policy, talking about terms that make sense within our organization, within our boundaries in our organization, can really help as we scale our event architectures. And one way I really recommend doing, has anyone done event storming before here? Got about 4 or 5 hands. So event storming is a fantastic way to facilitate this. So what event storming does, what we can do here is actually get people in a room, get some post-it notes, and actually model out the event system, the aggregates, the domains of our system, right? And you could do this with a greenfield, you can do this with a legacy application, doesn't really matter. And to show you an example of this is one I did last year, like a car parking system, as a brief example. So as you can see here, we have the ticket machine at the top, which is the system, and then we have commands, right? Raise, create a new ticket. And then down here, a ticket has been created. We're raising these events. We actually can model this out using Post-it notes. Then we can actually group them up into boundaries, into domains, and map this over time. Well, this allows us to do, everyone in this room could probably read this and actually understand what this ticket system should be doing. From this, we can actually map this into our domain models, inside our events, and start building. So I really recommend if you're looking at starting an event-driven system or solution, event storming itself can really help. So when we have this, excuse me, the next thing is we have events, we have some boundaries, so we decided to kind of dive into this. So where do we start? How do we start implementing this solution? And the first thing we need to get our heads around really is this thinking asynchronously. So your application will have times where you have synchronous commands, as an example, or asynchronous events. So an example would be on the pizza ordering app. I make a query. It's a type of message, right? I make a query to get some information. This information is given back to me in a synchronous kind of request and response. So an example here, actually, this is actually called synchronous chaining, where we have one system talking to another, coming back to the user, right? So this whole synchronous communication pattern. Now here on the right, we have like asynchronous events. Okay, so an example would be here when you place the order of the pizza, of the pineapple, for example. We don't have to stay around and wait for this. This whole process happens asynchronously, and someone will come and deliver the pizza in the future. Now, if you map this into real-world examples, asynchronous events are everywhere. We live in an asynchronous world, okay? And often we need to map these things into our architecture. So you will have synchronous and asynchronous things going on. Now, when we map that to event-driven solutions, there's these interesting terms, these types of messages that you should be aware of. Now, there's not a direct mapping here, but I would say it's a loose kind of mapping here. An example on the left would we have the command, right? This is a type of message. A command represents the intent. A command can be rejected. So please place this order for the pizza. No, we've run out of pizza. Or no validation errors and things like that. These are commands going over the wire. Now the order service here says, thank you very much. Now the order has been created, raises an event. So on the right, we have an event. An event is a fact that has happened. It cannot be undone. It's just this immutable information. With this information, we can actually have consumers, and we can actually react to these things happening in our architecture. And the way we build our architectures is kind of split into a collection of patterns. I like to think of it like this. So we spoke at the start, when we lift the hood of event-driven solutions, what is actually in there? And this is some of the things we might see. So on the top left, we have like point-to-point messaging, we have streaming, we have routing, as an example. And your architecture will probably have some of these patterns in there. And then down in the bottom right, where there are actually some integration patterns, some domain-driven design patterns that can help you solve some of these problems that you will have when you build event-driven solutions. And what we're going to do now is actually dive into each of these in more detail. So as the order service, we've been given the task to integrate with a different service. This happens all the time. Like it could be something internally, it could be externally, whatever that might be. We decided to integrate directly, and we sent A, B, and C to the fulfillment service. Now, this can provide value. Yeah, we've done our integrations. But there are some things that we need to really consider here. One of them is, does the order service know too much? So we have the order service, fulfillment service. Does they need to know about each other? On the right here, we've also got like processing at the same rate. So what happens if we take too many orders in at once, and the fulfillment service is a third-party service, and we bring that down? So what will happen to the customer is this kind of request comes in, we talk to the fulfillment service, and the customer gets a bad experience. And also, what happens, if fulfillment fails itself? The whole chain will fail here. So a common solution people tend to use is something like queues here, right? Point-to-point integrations. So we put a message onto the queue that says, okay, well, this order has been placed. Can you please kind of process this information? The downstream consumer says, yes, I can, and I'll pull these messages off the queue and process them at a desired rate. Now that's interesting, that's powerful, because as the fulfillment service can only handle so many orders per second, and the order service is a completely different stack, it allows us to kind of manage these things. And again, isolated failures, we can actually do things like set up dead letter queues, which allows us to have messages and capture failed messages so we can replay them later on. Now, what I'm talking about here is this, which is this asynchronous point-to-point integration. And the best way to think about this really is you have A and you have B, and you want to communicate. And we typically tend to use queues to do this. Now, the interesting pattern here is we also have many different consumers, receivers. So we can scale out the receivers. So we have so many orders that come in, we can actually scale these things out. The way I like to visualize this is when I go Christmas shopping with my kids, which is an absolute nightmare. I do not recommend doing that. But when I'm queuing up, and there's only one cashier for whatever reason, this happens more often than not, I'm stood there, huge queue. But then what they do, or hopefully what they do if you're lucky enough, is they open up more cashiers to process this queue. So we start fanning out to all these different consumers. And that's exactly what's going on here. And the interesting thing here is will consumers pull messages off the queue? Now, if we link this back to serverless services, AWS, this is Amazon SQS. Is anyone using SQS here? Cool, a few hands. So it almost scales infinitely here and allows us to do things like FIFO queues. So if ordering is important to you, we can actually do FIFO messaging processing here. And also like dead letter queue support. So again, part of your event-driven architectures, your journey itself, will probably have some kind of queuing mechanism in there. And when we go beyond queues, what's next? When we want to notify downstream consumers things have happened, right? That an event has happened. And James spoke about this in his talk, that most people, and this is definitely what I'm seeing, most people tend to fall into the routing kind of patterns. So we want to notify the 3 of these services that something has happened. So we decide to do this manually. We can integrate with them 1, 2, 3. But again, what happens when the order service knows, too much? How do we handle isolated failures and this duplication of effort of integrating each party into the system? Now, what we can do here is actually create the order created event. We had this earlier. We can use an event broker, and we can notify downstream consumers that stuff has happened, which is super powerful. In fact, what we're talking about here is the publish-subscribe method that James mentioned this in the talk earlier. But what this allows us to do is create a router in the middle, an event bus, so we can actually say as a producer, an order has been created. I'm going to put this onto the bus and kind of forget about it. It's not my job as the order service to manage the downstream consumers. Downstream consumers come along and say, okay, I'm interested in this event, and I'm going to react and do something. So a common pattern might be with EventBridge or into Lambda as an example. Now, the interesting thing again here is we're talking about push model. So queues we're pulling, and now we're talking about pushing. So an example here is using Amazon EventBridge. Okay, so there's serverless event bus, being able to route events to downstream consumers. The interesting thing here, we can also do filters and transforms and target over 28 different AWS services. Which is great. Now, the most interesting part for me, and this goes on from what James spoke about today actually, is this bit at the bottom, this integration piece using things like API destinations, SaaS integrations. If you have events that you want to go inside from third parties or outside of your systems or your architectures, you can do this with EventBridge, and EventBridge will manage these connections for you. So that's super powerful when we're talking about flow, as James was earlier. The next type of event system that you'll have in your architecture is streaming, event streaming. So we've got point-to-point, A to B, we've got pub-sub, out to everyone in the audience, and now we have streaming. So this unbounded data, thinking about all this enriched data, real-time data, again, James mentioned this with the value of data, the value being higher when it's in more real time. Okay, so we want to process this. So how can we do this? Again, what serverless offerings are there? And one very popular one, actually, that customers tend to use is like change data capture, being able to listen to changes in a database and react to them. No code needs to be managed, and we can create DynamoDB streams to do this. So on an update, create, or delete, we can listen to this and react to it. And when we start thinking about these patterns and thinking about these integration patterns, it kind of opens the door to a lot of things we can do. So we have point-to-point, we have pub-sub, and we have streaming. Your architectures will have this as your journey, as you start to explore different patterns and different solutions. Now, you will also come across problems, questions from your teams. And you'll also come across things like integration patterns. Okay? How can we solve some of these issues? So let's have a look at some of these common questions that will come up. And there's definitely stuff I've seen in the past with teams I've led. First one is the big question, what goes inside our events? Okay? So we started off earlier. We had various different event types in this talk. Now, the order service says, okay, we're going to place the order placed event. And the downstream service says, okay, it's a bit sparse, it's a bit small, but it's okay, we'll take it as it is, it's fine. Because what we can do is actually go back and get more information, okay? Now, from a consumer's point of view, this is fine, this is okay. But what tends to happen when you scale your consumers out, you get more and more requests back to the producer to pull this information out. So now we're creating a back pressure on the producer to get this information. And I'll tell you a quick story. When I was working in a startup, we implemented this pattern. We accidentally implemented this pattern. And I remember walking in one day, and one of the developers says to me, Dave, we've gone viral. You won't believe it. Look at the graph. Look at the requests coming in. In this example, would be the order service. I was a bit skeptical, like, well, what's going on? What's going on? And as we dive deeper into the logs, we actually found that all that's really happened is more consumers have come on board requesting information from the producer. Now, if you need up-to-date information, if your consumer does need up-to-date, this is a valid pattern. But what you don't want to fall into is the accidental coupling, this accidental pattern. Now, talking about enrichment, talking about integration patterns, what can help us mitigate against these issues if we really wanted to. There's a pattern called the content enricher pattern. And what this allows us to do is have the producer stay simple in contract, because often the producers may want to stay simple in contract, have that user ID and that order ID. But the consumer over here wants more information, right? So they say, okay, well, I need more information. You either put it in or I can kind of get it. So the content enricher pattern, what that allows us to do is create an enrichment in the middle, right? So some middleware in the middle that says, I'll get the message, I'll get the event, I'll enrich it with some information and give it to the downstream consumer. Some interesting things start to emerge with this. So one way of doing this, we see many customers doing, is using event bridge pipes. Is anyone using pipes here? Okay, one or two people. So Event Bridge Pipes is an interesting service. We released this at reInvent last year. And what this is, going back to point, right? This is a point-to-point service between A and B. A common example would be DynamoDB straight into something like Event Bridge. Super powerful. So we can actually listen to changes again using change data capture and publish this out to many downstream consumers. Event Bridge Pipes handles this point-to-point connection for us, but we can also start to do transforms in the message as it comes through. So we take the DynamoDB schema, the event, and we transform it into an event that downstream consumers can understand and use, which is powerful. But the most interesting part for me in this particular problem is the enrichment part. So as the message comes through and goes to the downstream consumer, we can actually enrich it using Lambda or step functions or API destinations here. So we can actually go out, enrich the data, and then pass that on to downstream consumers. So this is a super powerful pattern. So if you're interested in that point-to-point, I highly recommend checking that out. The next problem that you'll often see is this one. As you're using message brokers and you're using services, is we have large messages that we want to produce and we want to share. But the broker only supports a particular size. An example would be SQS or Event Bridge, 256 kilobytes, right? But if your message is larger, what do you do? Example here would be something like claim check pattern. This is an established pattern. What this allows us to do is get the message, get that information, and before we actually produce it, we store first. We store information somewhere, and then what we can do is pass that key, that reference point with the event to the downstream consumer, and the downstream consumer can come and get this information and enrich their payload and move on. Now, an example, a serverless example would be something like this, where we have a Lambda function right on the left is the producer of the event. Now, the first thing the Lambda function could do is store information inside of S3. Okay, store the event in there, And we can even use something like a pre-signed URL with a TTL on it. So we can actually say, okay, here is the URL, here's access for downstream consumers. They have an hour, 2 hours, whatever that might be. So we use EventBridge. EventBridge, we create a rule, and the rule can target step functions. So we're passing an event, we're doing some routing, and step functions get triggered. The first thing step functions does here is actually go and get the information from S3, and again, move on. So it's a very, very popular pattern if you fall into these particular problems. One other thing that will come up for sure is actually the coupling through the contract itself. So consuming events as they are. Now, if you're integrating with any services or any producer, you will fall into some of these categories. And the first category here is the conformist. Now, what we're doing here is actually looking at domain-driven design, bounded context mappings, and how they apply to event-driven architectures, because there is a connection here. So an example would be, A, the producer is producing an event. We, as B, consume the event as it is. Now, that might be fine, okay, but we've got to consider a few things here. An example would be if we integrate with a SaaS partner, Salesforce was mentioned today, and we decide to take this event model and we decide to do something with it in our domain. Now, that might seem okay at the start, but what we're actually doing is we're binding our implementation details, our models, with the Salesforce model as an example there. Or even inside your organization, in the orders domain and the fulfillment domain, if we take the orders event as it is, and we decide to do something with this model, we are coupled by the contract of this model. And this is the default way of thinking about it. This is the default behavior of event-driven systems. And one way we've got to think about this is thinking about what options do we have. Now, one of them is we introduce an anti-corruption layer. So rather than the fulfillment service takes the order information, and now we can transform it in a language and a model that our domain understands. And this is important because if we don't start thinking about these patterns and these integration patterns, excuse me, we'll be bound. We don't want to be bound by the contract of the system itself. So we might think on paper that we're decoupled, but in fact, you can be very coupled through the schema and the event. So anti-corruption layer, what this allows us to do, as we get the information in, we can actually manipulate that event. The first thing we do is manipulate it, change it to a schema, this ubiquitous language that we understand as a domain expert, and then we use that. And we've got one place to change this. Excuse me. And here we have what we call open host service. So what we decide to do here as a team is actually push back onto the producer and say, you're not going to raise this order placed event anymore with this particular information. We, as an organization, as a boundary, have decided to raise this public interface, this public language. And that's what we use when we talk about open host service. So these different patterns, different communication styles, when we're using events and messages to communicate. And there's an interesting thing here, which is that the communication level, the required communication level increases depending on which pattern that we use. So an example down here is the open host service requires less communication. Okay? So what I mean by this, we have this upfront communication, this agreement of what is in the event, what should the event be. But as time goes on, we've had that public interface, this public language, that actually the communication as time goes on isn't really there, isn't really needed as much as some of the others. An example, the opposite to that would be the conformist. Requires a lot of communication. Now, if you start breaking schemas, start removing properties or adding properties, how are people going to discover this? And are you going to break people in production or low environments? So the level of communication differs based on which one you choose. Now, if you want to dive, there are more. If you want to dive deeper, I have resources at the end. But I really recommend kind of diving into this and figuring out which kind of pattern you want to use. And one thing I recommend, actually, is the ability to think about, we call it kind of private and public information. And so an example here would be, we are the order service. Our order service has 10 engineers on it. We've broken this order service up into submodules. We're using EventBridge, we're using a broker in the middle to communicate between ourselves within this domain. Now, we can have type DW in there, going back to that example. We can have this information in there, implementation details in our events, in this private boundary between us. We can use systems, we can use messaging and events, that's fine. This is completely different to when we actually talk publicly to people, across teams, across boundaries. We actually want to nurture these events, this public information, completely different to the way we actually nurture our private information. The technology under the hood is exactly the same. We can use EventBridge to do cross-account communication if you have boundaries here. But it's all about the design. It's all about how we nurture and how we create these events can really have an impact on your architecture. And I just kind of want to summarize this section by saying this is that when, as I mentioned before, when you're diving into event-driven solutions and architectures, we have a producer, we have a channel, we have a consumer. Does that make us event-driven? Probably not. When you start to implement these things and start to come across some of these problems, because you will come across problems, what solutions are there out there? And it's really understanding that event-driven architectures really just are a collection of these patterns. And there are tons of patterns out there, actually, and I have resources at the end that can help you mitigate some of these issues as you are going along. And what I really recommend you do, if you want to dive deeper, actually, is domain-driven design itself really, really complements event-driven architectures. So we're talking about boundaries and bounded context. We're talking about mappings and all these things from this book that's over 20 years old can really be applied to what we're doing today. So if you want to dive deeper, I highly recommend checking this out. So the next thing that comes along is this. So we have done our event storming, or we've got some events. We've done this design up front that we can identify domains and aggregates and this stuff. We decide to use some queues and messages and event brokers, and our architecture is scaling and growing over time. So the next thing we don't often speak about or look at is more about operational maintenance of your event-driven solution. This is a huge common problem when I speak to people in the community around event-driven architectures. Things like discoverability and standards. What does it all mean? And it's interesting when you map this over time, is when we build event-driven solutions, we are promised this high agility and this low complexity. Right? This is why we want to be event-driven and have these events and have these solutions. And it is there. I've been there. This is why I'm so excited by this. But what tends to happen over time is the high complexity. We move into high complexity and this agility slows down. And if you're really unlucky, you actually end up in number 3, which is this like low agility and high complexity. And then you kind of question why maybe we're doing this in the first place. And if you're looking at it and read a lot about event-driven solutions, you'll see this term come up over and over and over again. Okay? That producers should not know about consumers. Okay? And for me, this is the fundamental problem when we're talking about operational maintenance. This phase, this sentence. And let's just have a quick look at an example. So we've seen this throughout this talk, and what we decided to do, we add more producers, more consumers as time goes on. This is the whole point of event-driven solution. As evolutionary architecture, the events are already there, so let's just consume them and add more features onto our architecture, onto our software. What tends to happen here is that we add more event buses, as an example, more accounts, it could be an example, more producers, more consumers, and our architecture is growing. Now, you will come across these kind of questions. What events do we have? So remember, this whole architecture piece is probably going on for a year or maybe more, this whole journey. So what events do we have? What payloads? What goes inside the payloads of the events? And who's consuming what? Remember, people come and go throughout the organization. What events do we have are super important when you have new features come on board? What events could I reuse to actually build this feature? And coming back to this, when we said producers should not know about consumers, this is 100% right. Producers themselves should have no idea about the consumers. We are decoupled. But it doesn't mean, this is the thing, it doesn't mean we can skip governance. Okay, coming back to governance, I know there's another talk on at the moment about governance with capital One. It's super, super important. And what I've kind of distilled here is 3 main areas about governance, about standards and things that can help you as you're on this journey, as you're implementing, to avoid some of these common mistakes. So number 1 here is thinking about standards. Okay, so here, thinking about what goes back to this, what goes inside your events. You have 50 events, 100 events, 200 events, thousands of events inside your organization. Now, the detail of the event, the envelope itself could be different, and probably is different, but you're still within the same organization, so what standards do you want to put inside of there? Examples could be correlation IDs. Examples could be the domains themselves, or timestamps, custom timestamps if you want to do this. This becomes very, very interesting when you start using things like EventBridge. We can create a rule on your standard patterns, and you could say, I want to listen to all the events that are coming out of this particular project, this particular team. I can actually set up an event to listen to that domain. So interesting things start to happen about here and help with observability. So I really, really recommend if you're starting, just think, is there standards we can use here? Is there a common SDK that we can build on the team to scale out in the organization? Another thing here is what I like to think about event-first thinking, right? Think about your API contracts. Think about your APIs in your organization. We love APIs. We nurture them. We have specs for them. We have tools for them. We just love to version them. Everything about APIs, right? But when it comes to events and designs and contracts, it's completely different. And thinking about this and changing the way we actually think about event-driven solutions into this. It's actually treating events as this evolutionary thing where we can identify, define them, and implement them, but we need to go back and nurture them, version them, think about them, keeping them at the forefront of our architecture, because they're the whole point, the whole reason why we're communicating using events. So if you're interested, I've done a whole 45-minute talk here, literally diving into this section. Again, the resources are at the end. The next one here is about discoverability. Who is using my events? How can I find events? And you'll see this here with using schemas as an example. So EventBridge have a fantastic feature I personally love using discovered schemas. So you can turn this on, and as events fly through the registry, through the bus, it'll actually document the schemas for you. With the schemas, what you can do there is also download code bindings in TypeScript, Java, .NET, as an example. Have the models accessible to you as you're using the service. Very interesting, very powerful. Another thing here, which was mentioned in the keynote, Async API. I worked on this team for about 10 months full time. But specifications that are coming out to help you document your event-driven architectures, your channels, your publishers, your consumers. Because once we have standards, the tooling emerges. Okay? And there are hundreds of tools you can use here with hundreds of different languages. So again, if you're a fan of Open API, this is a fork of that, and you can dive deeper and start to document your systems. And I'm such a believer of documentation and schema-driven stuff, super geek actually, that I created this tool here, which is Event Catalog. I met a couple of people today actually using Event Catalog, which was pretty cool. What this allows you to do is document and visualize your architectures. Again, big problems that people are having is just seeing what is going on, seeing and discovering events and visualize them. And visualizing them can really help you actually figure out what's happening in your architecture. And then finally here is about communication. And I talked about communication throughout the talk, but really, really embracing this. Really, really thinking about these boundaries. So we have the order domain, we have the invoice domain. The models inside the boundaries, right? The orders. Now the orders can be completely different on the order domain than they can be on the invoice domain. Remember, we're using events as a way to communicate between boundaries. You might go for a public language that we use in the middle, but really embrace the fact that languages are different between boundaries that can really help you build your event-driven solutions without kind of conforming to different kind of models and languages within the boundaries. So again, communication can really help, because when we go back to this slide, It's all about moving away from number 3, right? We don't want to have this high complexity and this low agility. We want to move up and keep in this high agility and this low complexity that event architectures can provide you. And these patterns can help with that. And I just want to summarize everything that we spoke about in this session. I mentioned at the start of this session that event-driven architecture is a journey that we go on. We don't just have a producer and a consumer and a channel. We're not event-driven. If we have that, we're just on the path to be having event architectures. I kind of highlighted these benefits at the top, the reasons why we want to be event-driven, and you can be there. You can get there. I've seen it. It's fantastic. But down here, we also have the common pitfalls and mistakes that people tend to make, and we can avoid them. We spoke about the initial design, events themselves. Why do we care about events? Well, events tell the story. We spoke about understanding behavior first, right? Actually, rather than implementing first. And event storming can really, really help you identify these boundaries and your events and your architectures. In the next part, we spoke about implementation with event types, right? Commands, queries, and events. This can really, really help you when you build your event-driven solutions. We have messaging patterns like point-to-point messaging, pub, sub, and streams. As you go on your journey, you will probably inherit some of this, so understanding these patterns can really help. And then we have integration patterns, and understanding that EDA really, for me, is a collection of patterns, and understanding these can really help you evolve your architectures. And then finally, we spoke about this, which is operational maintenance. And I really recommend do not skip over this section. Think about standards of your events. Think about discoverability up front and communication boundaries. Reduce the complexity. You want people to find your events and actually innovate on them, right? Because as James mentioned earlier, we lower the cost of integration. Even within our organization, we have this fire of innovation that happens and things we can explore. And event-driven architectures can really, really help you with this. We mentioned serverless services, SQS, EventBridge, and DynamoDB. We mentioned EventBridge pipes as this point-to-point communication, right? Being able to do enrichment and filtering along the way. So if you want to dive deeper, I recommend checking out some of these services that can help. We have serverless espressos. Anyone got a coffee yet? A few people. So if you need a coffee after this session, I recommend going over there because this is a fully event-driven system. We use API Gateway, DynamoDB, we use streams, we use EventBridge and step functions. And if you want to dive into this, feel free to grab one of us over there and we can help you and explain this. It's a really great way of looking at this. And then finally, we have loads and loads of resources on serverless land. Hands up if you're using serverless land. Okay, it's about half the room. Awesome. So this is a website that we run as the DA team at AWS. So we've got tons of patterns on here, tons of workshops. We have resources. So again, if you want to dive deep, if you want to learn, if you're starting your serverless journey or your level, you're deeper into it, I recommend checking these resources. And finally, loads of resources here. My talk resources at the top. So everything I spoke about, you can find here. And then also at the start of the year, I started doing EDA visuals, which is over 50 bite-sized visuals to actually help you learn about event architecture. So if you've got like 5 minutes spare over a coffee, you can just pick a visual and just learn something. So I've created these, and these are quite popular. So I hope they help. And with that, I think I'm on time, and I just want to say thank you very much. I'm here all day, so if you've got any questions or want to discuss EDA or anything, just feel free to grab me. But thank you very much for your time and coming to the session.